Hello and welcome to this lesson on base 5, number representation. So we are going to have a quantity and we're going to represent it by counting in fives. Now, the digits in our number system that we know today have evolved slowly over time, as you can see here, to what we have today. And it comes from these Hindu Arabic numerals. To emphasize that these are just symbols, we can use any one of these to represent our digits when we're representing a number. We just happen to use this bottom one. But it doesn't have to be, and these change over time, and we are just used to these last ones. Just if you were born in around the 11th century, you would be used to another way of writing your numbers. But it doesn't change the quantity that it's trying to represent. So to not get too confusing, we will stick to our familiar representations and symbols. But to emphasize what these symbols are actually doing in a number representation, we are going to count in fives instead of our usual 10. So if I, for example, take 23, I'm going to say it in words first. 4 groups of 5 and 3, I'll say ones. Some people say units. Some people say singles, whatever you want to call it. So if you want to represent that with symbols, you could say, okay, well, I have, let's suppose a line is a group of 5, and then I'm going to have 4 lines, and then 3 little single rocks, for example. As soon as I have 5 of a group, 5 of these rocks, if I added 2 more, now that would become a group of 5 that rolls over and becomes it and turns, I'll scroll up here a little bit, turns into a group of 5 and therefore another finger. And then I would have 5 fingers. I just call them fingers, 5 little lines. And that would make a group of 5. Group of 5. Really 5 fives. So this in total would be 5 times 5, meaning 25, or 5 squared. And that would become a new symbol, which let's make it a square, or a little hand. And you have this very basic way of representing quantities, each time introducing new symbols when your group size is full. So for example, we could have a quantity like 37 and say that is one group of 25. How much is left over then? I have 12 left over. So that's 2 groups of 5 and another 2 ones, if you will. So in this basic version, we could represent that number by a hand or a square, 2 fingers, and 2 little rocks. But it becomes tedious as your numbers get bigger to introduce newer symbols. And that's where the Hindu Arabic numerals came in. They said, let's just recycle the same digits, because all we need to know is that there are 2 rocks. And then the next place is going to count fingers or lines, and there are 2 of them. And the next place is going to count the squares or hands, if you discuss the one-hand system in this way. and there's only one of them. So as long as we agree that from right to left, it's going to be representing the number of ones, the number of fives, the number of 25s, or 5 squared, and we don't miss one, then we don't need these symbols anymore. We only need this. And any single digit, any single place will only have the following possibilities. I can have 0, 1, 2, 3, or 4. Because as soon as I have 5, it rolls over to another group of the larger size. So these are the only digits we can use. And we can make longer and longer representations, still recycling these 5 symbols. We don't need to make newer and newer symbols. So this is going to be our base 5 representation. So this is going to be our base 5 representation of the quantity 37. So there is a big difference between our decimal number, and our base 5 number. And if we were to write this 1, 2, 2, we don't want to get confused and read that as 122. So what we do is we write the little word 5 at the end, and then everyone knows, okay, that is a base 5 number. Because we're so familiar with our digits, we could have used some other symbols, but there's no need to get too fancy. As long as we remember, with the little 5 there, we're counting groups of 5. So let's see some examples to practice this a little bit and keep the concepts separate. We have 2 kinds of conversions. The one kind is, given a base 5 number, what is the decimal version, the decimal quantity that you are counting? So let's make a new page here and start fresh. So we're going to do this exercise 7.3, number 1A. So it says, state the decimal number for the following base 5 numbers. And you see how they have a little 5 next to them? So I'm not going to read this as 1,204 because it's not decimal. It's counting groups of 5. I'm going to read this as 1204 base 5. And it might be convenient for you to write this left to right or right to left, depending on what works for you to break it up. But starting right to left, this is the ones, then I'm counting groups of 5, then I'm counting 5 squared, or 25, and it would just go up in powers of 5 like that, and 5 cubed, because 5 groups of 25 would be 125. So this then says, I have one group of 125, another 2 groups of 25, I have no groups of 5, and I have 4 ones. But it is important to have that 0 there, otherwise I wouldn't know which digit counts which one. So it's important to not miss those zeros. Every place has a specific thing that it's representing. And then we can calculate that. I should probably have brought my calculator. Let's quickly get a calculator going here. And we can calculate that. I encourage you to take out your own calculator, or you can do it in your head. So we have 125 there, 2 times 25. Then the 0 times 5 is nothing, plus a 4. So I get 179 is the quantity that this base 5 number represents. Again, this is decimal, and this is base 5. I'm not counting with the same group size, so the representations will look very different. Let's try the second one. 13214 base 5. So again, you can also, I like to plan it out instead of starting to just write it down, but it's totally up to you. Here I'm going to count the ones, then I'm going to count groups of 5. Sorry, that doesn't even look like a 5. 5. And then I'm going to count 5 squared, or 25, then 5 cubed, then 5 to the 4. Whether you write the powers of 5 or their actual values doesn't matter. One group of 5 to the 4 plus 3 groups of 5 cubed plus 2 groups of 5 squared plus 1 group of 5 plus 4 singles. Put that in. It's handy to know what these guys are. 5 to the 4, we'll get used to 625. 5 cubed is 125. 5 squared we should know is 25. We get our calculator and let's see what that is. So I have one group of 625 plus 3 groups of 125 plus 2 groups of 25 plus 1 group of 5 plus 4 singles. I get 1,059. That is now 1,059 because this is a decimal number. This first one was not 13,214 because that was a base 5 number. So the way I read it is different. Let's do one more. 1003 base 5. So an alternative is to not do the little arrows underneath and just then start right to left so that I can make sure I don't miss anything. It would be 3 ones plus 0, this 0 over here. I said no arrows. 0 groups of 5. If I go further in, I'm counting 25s, and further in, I'm counting 125s, increasing powers of 5. And if I calculate that, it's simple enough to be 128. So when there's a little subscript at the end of a number, it says what the group size is. Now let's move on to the other kind of conversion, which is given the decimal number, what is the base 5 representation of that number? So the first one is the decimal number 116. Now there's different ways to go about this. I'd like to propose a little table to just keep things structured and organized. So this is my decimal quantity. Whoops, I have to learn how to write quantity. I want to represent that as a base 5 number, which means I have to break it up into pieces. So a first column, and this isn't the only way, this is just my suggestion, could be to write which power of 5 am I going to look at. Then, how many, let's say how many times does that fit? Then what have I used? And what do I have left to still count? So let's make our little table and see what that looks like. Again, this is just a suggestion. If you are comfortable with with another way of writing this or finding the answer, go for it. This is just, if you're not sure, a table is often a very good idea to structure and keep track of your answer. So now first I have to figure out what is the highest power of 5 that can go in there. Well, I know 5 cubed is 125, and that's too big. So that's not going to fit even once. So I'm going to go 5 squared, which is 25. How many times does 25 fit into 116? If you want to use your calculator, that's fine, but we're only looking for whole times it can fit. So 4. If I fit 4 groups of 25, then I've used 4 times 25, which is 100. And I have left 16 to still account for, because the whole quantity has to be accounted for. Once I've started with a power of 5, I have to go all the way down. 5 to the 1 is just 5, and 5 to the 0 is just the 1s. So, in what's left, I have to fit groups of 5. I can fit 3 of them using 15 and having 1 left, which the last singles, the 1s, will mop up. I can fit 1 into 1 once. I've used 1. I have nothing left. So ending with a 0 tells me I've used everything. Now, I made my lines way too big, so let's erase these to not waste my space. Didn't really know how much space I needed, so oh well. Let's go back to a pen here. So, 116 is then represented. You can do right to left if it helps you, starting with 1s, 1 group, one single, one left over after I fit in as much as I could. 3 groups of 5, 4 groups of 25. So 4, 3, 1 base 5. Next one. Oh, is that number 2? No, that's a B, isn't it? So the quantity is 789. Again, that's my decimal quantity. I want to figure out what is the power of 5 that I'm going to fit in here. Then, how many times? How many times does it fit in? What have I used? What's left? That is going to be how I make my table. Might not be how you do it. That is how I'm going to do it, because that works for me. And I can explain it to anyone. Now the challenge is to find the highest power of 5 that can fit in there. With a little experimentation, 5 to the 4 is 625. The next one is 3000, so it's too big. And once I've done that, I cannot skip another power of 5 at all. So, first of all, 126. Sorry, 625. 126. 625 fits in once. A group of 625. I've used 625. I have left simple subtraction because I had 789. I'm using 625, so 164 is still left. Now, I want to fit in as many 125s as I can. I can only fit in 1, huh? I've used 125 of this 164. How much do I have left? Well, you can take your time. I'm going to slow down here. Pause. If you need to use a calculator, that's okay. It's always nice to try and do it in your head to keep things working, keep you sharp, but you don't have to if you don't want to risk making a mistake. 39. And you can check that I couldn't fit in more because I only have 39. My group size is 125 at this stage. Couldn't fit in more. So 5 squared is 25. I can fit in some 25s. 1 again. Oh, it's not very exciting. But I've used 25 of the remaining 39. How much do I have left? 14. Now 5 is what I want to fit in. I can fit a couple in using 10 and I have 4 left. See, 4 is too small to fit in another 5. And the ones will just mop it up using all of them with nothing left, and I'm done. So 789, which I can't see right there, is going to be 11124 base 5. Because from left to right, it's going bigger group size to smaller. From right to left, it's ones and increasing power of x, whichever one works for you. But notice how they're all right there in the table. All right, let's try one more. We have one more. Ooh, we have a big one. We have a big one. Let's do it. Just need to make a bigger page here. New page, rather. So let's see. That is number C, and it is 3,186. Ooh, that is a big one. But the nice thing about the table is nothing is going to change. I'm looking for powers of 5. How many times does it fit? What have I used when I fit some in? And what is left? Table doesn't change. So when I have a consistent method, it gives me confidence that you can give me whatever number you want. I know what I'm going to do. I'm just going to look for the largest power of 5, and we can check. What is 5 to the power of 5? I've learned 5 to the 4. 5 to the power of 5 is what? Take out your calculator. Do the calculation. Don't wait for me to do it. Be proactive and do it. 3,125. Pause the video if you feel I'm going too fast. Do it yourself. Once I have that, I have to go down all the powers of x. There's no skipping of any of them. 3,125 can fit in once. I've used 3,125. I have left? Well, just subtract it from what I originally started with, and you'll get 61. Not much left, but I can't skip anything. I have to emphasize and say, I cannot fit in a group of 625. 0. I've used nothing. I still have 61 left. 5 cubed? No, it's 125. Doesn't fit. I've used nothing. 61 left. But 5 squares, 25. Yeah, I can fit in a couple of them. Twice. I've used 50. I have 11 left. How many 5s can I fit in? 2. I've used 10. I have a 1 left. And the 1s will just mop those up, using everything with nothing left. So we can actually write up here. The base 5 representation of this number is 100221. So hopefully this helps you to better understand base 5 numbers. We can extend this to other bases, but for now we want to just focus on the 5. Please remember to click the like button if you enjoyed the video, and to subscribe if you want to be notified of more videos. Also, please visit me on my Patreon page if you want to support me in making further content. Thank you.